Hi, welcome everyone to today's topic of airborne software development and certification. Today I have with me Dr. Sudha Srinivasan from Aeronautical Development Agency, myself Dr. Gracie Philip from Semilac. We both are IV&V practitioners for the past 2 decades. Sudha has worked mainly in the field of weapon systems and EW systems, and I have worked in flight control systems and avionics. We both would like to take you through a flavor of DO178C from our experience, the new variant after DO178B. Software considerations in airborne systems and equipment certification is a guideline dealing with safety of software used in airborne systems. We have planned the presentation in 2 parts. Part 1 starts with need of a robust process, and we will go through the planning process and development process. And in part 2, we will take you through specific processes like software development process, integrated process, field loadable software process, and user modifiable software process. Sudha, will you take them along from hereafter?
Thank you, Gracie. We'll be talking predominantly about the software lifecycle processes and its importance. Before that, it's important for us to quickly look at the information flow between system and software lifecycle processes. Now, if you look at the system lifecycle process, we find that there is a very strong link to the software lifecycle process. The top level requirements are all from the system engineering phase, which are traced down the line. So, as represented in this figure, while the system requirements, the software levels, the design constraints and hardware definition flow from the system lifecycle to software lifecycle process, there is also a feedback of software requirements and architecture, error sources and fault containment boundaries from software lifecycle process to the system lifecycle process.
Sudha, can you quickly tell me how standards can help us?
Sure, Gracie. Standards are a means of specifying the requirements. They put us in perspective, they bring in the best practices. By using a standard, there's also easy communication among stakeholders. The software development processes are documented in standards, and it is the process maturity that contributes to a project's success and thereby the organization's success. RTCA DO178C, that is widely used in the civilian aircraft industry, is now being adopted in the military aircrafts as well. We also have our own DDP MAS released by Semilac, and the DRDO standard for software development released by DRDO that bring out the best practices and are now being followed by various projects.
So why DRDO brought out another standard?
Now, we know that DRDO caters to different types of software like safety critical, mission critical, ground-based software, simulation software, research and analysis software, and so on. So there was a need to normalize the processes followed across DRDOs. Hence, a technical committee was constituted with members from ADA, ADE, ASL, CARE, Semilac, RCI, SAG, DG Medcos, and DRDO and ADA together released a standard called the DRDO Standard for Software Development. This document incorporates the salient features of international standards, namely IEEE 12207, MIL Standard 882E and DO178B that are used in the field of military and avionics software. Many practical experiences of members and other teams have been captured in this document to provide unique and easy to refer technical guidelines. So, apart from all the system processes prior to software development process itself, and the system processes post-software development, there is also a miscellaneous section addressing a number of important topics. Now, the system processes as shown in the diagram prior to software development includes the user requirements, system requirement analysis, system safety analysis, acquisition, and supply. Now, in the software development process, we have described the activities for the planning phase, the requirement phase, design, construction, and integration as a part of the software development phase. The hardware-software integration testing, system integration testing, and user acceptance testing as a part of the qualification testing. The software configuration management, review, accomplishment, and also reuse management is addressed in detail in the DSSD. Now, the system processes post-software development includes installation, acceptance, operation, maintenance, and disposal. The tools and test rigs, additional software items, case tools, transfer of technology, and tailoring guidelines are covered in the miscellaneous section.
So if I follow DSSD, the DRDO standard, will I be complying to DO178C?
Yes, Gracie. In addition to the processes described in DO178B, DSSD also addresses the topics important for the software development lifecycle like acquisition and supply, system safety analysis, criticality level, software reuse management, installation, acceptance, maintenance, disposal, process automation, case tools, transfer of technology, the documentation needs and templates, SQA and IVNV requirements, review mechanisms, and tailoring guidelines too. Now, coming to DO178C, the software considerations in airborne systems and equipment certification. This is primarily a process-oriented document. For each process, the objectives are defined and a means of satisfying these objectives are described. So the guidance basically includes objectives for software lifecycle processes, means of satisfying the objectives, description of evidences in the form of lifecycle data, independence, lifecycle data and control categories. Additional considerations include the previously developed software, tool qualification, and product service history.
What are the additional topics covered in DO178C compared to DO178B?
Yeah, apart from the contents of DO178B, DO178C also addresses tool qualifications in DO330, the model-based development and verification in DO331, the object-oriented technology and related techniques in DO332, the formal methods in DO333, and there is also an FAQ on the standard that is addressed in DO248C. Now in DO178C, there are 5 levels of failure condition categorization, namely level A, where the consequence is a catastrophic failure, level B, where the consequence is hazardous, severe to major failure, level C, where the consequence is a major failure, level D, where the consequence is a minor failure, and the level E, where the consequence has no effect.
So when we adopt a standard, we need to clearly know the advantages. Shall we list the advantages of DO178B?
Yes, of course, Gracie, we should. So in DO178C, proper links to system engineering is provided. When there is meticulous planning and traceability established across all life cycle phases, the errors are bound to be minimal. There is flexibility in adopting any of the software development models. The certification aspects are finalized in the early phases and documented with PSAC, thereby removing ambiguity. There is flexibility in documentation. Yes, the tool outputs could also be used as evidences for the objectives. There's also a reuse advantage since use of previously developed software is very clearly addressed and there are clear guidelines on qualification and usage of tools too. So the software lifecycle model as such depicted in DO178C has the software planning process that comprises of 5 plans, namely the plan for software aspects of certification, the software development plan, the software verification plan, the software configuration management plan, and the software quality assurance plan. Next, the software development process and the integral processes are concurrent activities. The software development process comprises of requirements, design, coding, and integration. The requirements include high-level, low-level, and derived requirements. Design has the design description. Coding includes source code and object code. And lastly, the integration process is for executable object code with link load data. The integral processes running concurrent to the software development process are software verification process, configuration management process, the software quality assurance, and certification liaison. Now we'll be covering all these processes in detail. Shall we start with the planning phase, Gracie?
Hi, it worked yesterday. When you hear this, you know that you are in a software project where the planning and development processes are missing. The purpose of software planning process is to define the means of producing software that will satisfy its requirements and provide the level of confidence that is consistent with the software level. There are 5 plans, namely PSAC, Plan for Software Aspects of Certification, SDP, that is Software Development Plan, SVP, Software Verification Plan, SCMP, that is nothing but Software Configuration Management Plan, and SQAP. SQAP is Software Quality Assurance Plan. Apart from this, there are 3 standards, namely Software Requirement Standard, Software Design Standard, and Software Coding Standard.
Gracie, I have a question regarding the 5 plans. Are all the 5 plans required for a small system?
Yes, plans can be combined for small systems. Contents of the 5 plans can be described in 5 chapters of the same document. Repetition of the information across chapters can be avoided, Sudha.
Now we have heard about the Software Requirement Standard and Software Design Standard. What are they and why are they important?
Software Requirement Standard is to enforce the characteristics of the requirements like unambiguous, consistent, and completeness. It also brings out notations for high-level and low-level requirements for unique identification. Software Design Standard is to bring out general considerations like language issues, operating system usage for guiding the design team. It also brings out design methods to be used consistently by the design team. Constraints on the design like exclusion of recursion, avoidance of dynamic memory allocation are also part of the design standard.
Thank you, Gracie. We have now understood the Software Requirement Standard and the Software Design Standard. But now can we have some examples of the coding standards and the rationale behind using coding standards?
What is software coding standard? I would like to take you through some examples of coding standards. One example is subprograms shall not be called recursively. Another example is do not use dynamic memory allocation after initialization. What is the rationale behind coding standard? Idea behind the coding standard is to bring out software build which are predictable in terms of timing and sizing. Source code level transparency also is required, which is essential for maintenance. As per DO 178C, there are 7 objectives to be met in the planning phase and none of them need to be independently verified. It is to ensure that all plans and standards are in place. Software lifecycle environment is selected and defined is the third objective, which means that tools are selected and identified in the planning documents. Non-tool problems and limitations have been assessed. Tool qualification have been addressed. Additional considerations are addressed. Software development standards are defined. Software plans comply with the document. Development and revision of the software plans are coordinated.
So Gracie, tool qualification has been addressed in DO 178C. But the question is, can I reuse a qualified tool?
Yes, certification authorities can approve the reuse of tools if the tool use is exactly same as it is in the qualified tool and the qualification data is available. Transition criteria for planning process takes place when the following inputs are available for verification, that is all plans and standards are available: PSAC, SVP, SCMP, SQAP, and standards like software requirement standard, design standard and coding standards are made available. Stage of involvement reviews are to assess the adequacy of plans and standards with respect to the identified software criticality levels and to discuss the safety features and safety related software requirements. SOI 1 for planning phase is to review PSAC, SDP, SVP, SCMP standards and the tool qualification plan, verification data, SQA data and SCM data. Planning review records will contain evidences that are Planning process objectives have been satisfied, planning process activities have been performed, and life cycle data is correct and complete. It also shows evidence that planning documents are under configuration control. Similarly, it shows evidence that configuration certification process planning and quality assurance planning process are also in place.
Gracie, thank you for the elaborate explanation of the planning phase. Now, will I be able to reuse plan documents across projects?
Yes, Sudha. If properly planned, software lifecycle data originally approved on System 1 can be reused on System 2. The reuse of software plans and standards can include software undergoing minor changes only. From here, Sudha will take over and take you through software requirement process.
Sure, Gracie. Now we move on to the software requirement process. The question is, what is the purpose of the software requirement process? So in this process, the outputs of the system lifecycle process is used in order to develop high-level requirements, including functional requirements, performance requirements, interface requirements, and safety-related requirements.
Sudha, how important the software requirement phase in comparison with other phases?
Yes, Gracie, it is so important that efficient requirement capture helps in early detection and correction of errors. The graph shows the defect type, the phase found, the relative cost to fix. Now let's take an example. If the requirement error is found in the requirement phase, the cost to fix is 0. While if a design error is found in the coding phase, cost to fix will be 5 in a scale of 0 to 50. And if a requirement error is found only in the test phase, then the cost to fix is 50, which is very high. So the main objective in the software development lifecycle is to facilitate early detection and correction of software errors that reduces cost and time. So now let's take a look at the essential criteria for requirements. So requirements need to be understandable, should be stated once, should be complete, unambiguous, consistent, fully traced. The requirements also need to conform to standards and should be traceable. We have a few examples of a missing requirement, an incomplete requirement, and a wrong requirement. So now, if during an initiated bit, the LRU status will always come as fail, because the requirement needs to specify a do nothing for the time period of bit so that the false failure is not posted. So this was a missing requirement which has to clearly be specified as do nothing during this period. For an incomplete requirement, we had an example of an old aircraft that was damaged because the landing gear was raised while the aircraft was still standing on the runway. So the example for a wrong requirement that we could think of is Ariane 5, which resulted in the explosion and loss of the satellite. The software in Ariane 4 functioned perfectly. It had a successful launch, but Ariane 5 with the same software which was reused crashed because a requirement in the rocket's flight plan. Ariane 5 launched with a much steeper trajectory than Ariane 4, which resulted in a greater velocity and encountered the conversion error. So that was an implementation of a wrong requirement. So the objectives of the software requirement process in the software development process includes the first two objectives of the table. That is, the high-level requirements are developed. The related activities include the HLR are stated in quantitative terms. They do not describe the design or verification details except for specified and justified design constraints and so on. We have a second objective which mentions that the derived high-level requirements are not only defined but also fed back to the system process.
Sudha, can you give an example of a derived high-level requirement?
Yes, Gracie. Basically, derived high-level requirements are requirements that are not directly traceable to the system requirements. An example I can think of now is, suppose the high-level requirement says the system must work outdoors 12 months a year in Alaska. The derived high-level requirements for this particular high-level requirement is, we have two derived requirements, that is the system must work at temperatures below 0 degrees and the system must work in snow. We next move on to the transition criteria for verification of the outputs of the software requirement process, which takes place when the following inputs are available for verification, that is the system requirement specification, the software development plan, the software requirements data, the interface control documents, the traceability data, HSI test plan, procedures and test cases, and SQA and SCM data. Now, what are the important aspects of a requirement review? So the requirement review records will contain evidences that all requirement process objectives have been satisfied, requirement process activities have been performed, and the requirement process life cycle data is correct and complete. It also shows evidence that the requirement documents are under configuration control and the SQA records and certification licensing is in place. Now, the requirement review in DO-178C comes under the stage of involvement number 2, that is SOI 2, which covers SRD with high-level and derived requirement, the software requirement standards, the verification data, the SQA data, and the SCM data. Now the question is, why is verification of requirements so important? It is in order to detect and report requirement errors that may have been introduced during the software requirement process and to confirm that high-level requirements satisfy the objectives of DO-178C. So the objectives for the verification of outputs of software requirement process includes high-level requirements comply with the system requirements. The high-level requirements are accurate and consistent. The high-level requirements are compatible with the target computer. High-level requirements are verifiable. The high-level requirements conform to standards. The high-level requirements are traceable to the system requirements. And the algorithms are accurate.
Is the checklist really help in the verification process?
Yes, Gracie. Reflection of all the life cycle phases in a project, disciplined approach for designers and IVNV teams. It ensures that all the SDLC activities are covered. It prevents skipping of steps in a process, and checklist saves time, improves efficiency, and reduces cost.
Thanks, Sudha. Now, we move on to the next phase of the software development life cycle, namely software design phase. The purpose of the software design process is to refine the high-level requirements through one or more iterations in the design process and to develop software architecture and low-level requirements which can be used for implementing the source code. Objectives to be verified in the software design process are objective number 4, 5 and 3. Software objective architecture is developed, low-level requirements are developed, derived low-level requirements are defined.
Gracie, we see that DO-178C has defined low-level requirements, but are low-level requirements really required?
Yes, Sudha. During the software design process, software architecture is defined and low-level requirements are developed. The source code will be generated from these low-level requirements and derived low-level requirements. So, it is very important.
Gracie, shall we go through some good design practices?
Sure, Sudha. We can go through some of the good design practices. Fallback and recovery from system failures, positive feedback mechanisms in case of actuator control, restoration of interlocks in case of safety requirements, detection of external hardware failures, error handling are the important design features to be considered. Unnecessary feature implementation is to be avoided. Orderly shutdown upon detection of unsafe conditions to be ensured, and all interrupts, priorities and responses are to be defined for the real-time system. Transition criteria for verification of outputs of the design process takes place when the following outputs are available for verification, that is SRD, SDD, IDD, design standards, verification data, SCM data and SQA data. In the design phase, we have stage of involvement to review as per DO 178C. In this review, we cover the design description, design standards, verification data, SQA data and SCM data. Let us consider what are the important aspects of a design review. Design review records will contain evidences that are design process objectives are satisfied, design process activities have been performed, design process life cycle data is correct and complete. It also shows evidence that design documents are under configuration control and SQA records and certification licensing process is in place. The purpose of design process verification is to detect and report requirements and architectural errors that may have been introduced during the software design process and to confirm that software architecture low-level requirements satisfy the objectives defined in DO 178C. 13 objectives needs to be satisfied during the verification of the outputs of software design process. They are: low-level requirements comply with the high-level requirements. Low-level requirements are accurate and consistent. Low-level requirements are compatible with the target computer. Low-level requirements are verifiable. Low-level requirements conform to the standards. Low-level requirements are traceable to high-level requirements, and algorithms are accurate. In addition, there is another set of objectives. Let me start from objective number 8. Software architecture is compatible with the high-level requirements. Software architecture is consistent. Software architecture is compatible with target computer. Software architecture is verifiable. Software architecture conforms to standards. And software partitioning integrity is confirmed.
We now move on to the software coding and integration processes. So the objective for this phase is source code is developed. The related activities include source code implements and traces to the low-level requirements. The source code conforms to software architecture and software coding standards and so on. So the purpose of the software coding process is to implement source code from the software architecture and the low-level requirements. Now here we have just depicted when I wrote this code, only God and I understood what I did, and now only God knows. So this is what shows that when you write a code without requirements, design and appropriate comments, this will land the designers into this situation, which is very unpleasant.
Sudha, you said only God knows. Can we go through some of the good coding practices which are helpful?
Sure, Gracie. Now, what are some of the good coding practices? The comments detailing what the code is doing can make code maintenance much easier and help in finding bugs faster. It provide coding standards detailed enough to standardize the coding practices and coding conventions. All code must be compiled with all compiler warnings enabled and compiled without any warnings. Consider project learnings from historical projects and restrict all code to very simple control flow constructs. Now, DO178C also introduces us to two terminologies, the dead code and deactivated code. So we know that dead code has to be deleted, while the deactivated code needs to be handled in such a way that there is no inadvertent activation of the deactivated portion.
So, deactivated code is allowed in software. So, how do we design for that?
Yes, Gracie. There are some guidelines for designing the deactivated code. The design mechanism to assure that deactivated functions or components have no adverse impact on active functions or components. We have to provide evidence showing deactivated code is disabled for all environments where its use is not intended, and we need to apply full DO178C as per criticality level